jazz hands. Yeah, it suddenly feels very real after, you know, a lot of planning from myself and the others. So yeah, just first of all, thank you very much for coming. There's a lot you could be doing on your Wednesday evening when the weather's nice. So yeah, genuinely from the four of us, we're very appreciative of your time and yeah, having you here. And we've already spoken about so much and so many projects and things. I know that, yeah, we're going to learn as much as hopefully you will. My name's Mike. I'm one of the co-organizers with the other three. We're going to kind of do a little intro of each of us in a moment, so you'll know kind of our names and a bit about our backgrounds. But I'm just going to give you a very quick run through after that of kind of who we are, origins, all that kind of stuff. And I'm going to keep it as brief as possible so that we can jump into all the fun stuff, basically. I'll start with myself. So I work in the software world. I'm a programmer by day, TypeScript, Java, for an advertising company. Don't hate me. Yeah, basically, I love my day job, but I don't get to do any hardware stuff. So I was kind of going to all the Silicon Brighton meets and just looking for kind of kindred souls, and I bumped into these three and we got talking, and yeah, I've been doing hardware for about a year in my spare time, kind of tinkering and playing around with different LEDs and Picos and all kinds of stuff. But I would say on the hardware side more of the novice, just very eager to kind of get stuck in and yeah, learn and yeah, meet people and collaborate, and that's the whole idea for me of this kind of thing. John, do you want to come up and do your intro next?
Oh no, it wasn't that good. I'm John Durrant. I'm an organizer. We've been talking about this since December. So this has been a little bit in time in coming. So yes, I also originate in the world of software. Well, though I've done quite a bit of stuff in hardware. In fact, just down the other end of that road was where I started writing line encryptors 25 years ago on embedded 68,000 boards. So I've done stuff. These days I will tell you a whole load of more later, but actually, I gave up the world of software and being an enterprise architect and an IT leader. And these days, I teach people to actually code for these boards on Udemy and occasionally on YouTube. Well, and a lot on YouTube as well. So I chase likes for a living. Chetan.
Hi everyone, I'm Chetan. I met Mike at a code bar actually, and then Mike was asking, he was saying like, there should be a hardware meetup, maybe we should start one, and I was just like, yes, definitely. So yeah, I'm really glad this is happening, and like kudos to I mean, all of you guys for kind of getting this all set up. But yeah, so my day job is I work for a company called Clockwork Dog. We're a very small company of 8 people. Based in Camden in London, and we basically make control systems for immersive theatre, escape rooms, basically like physical experiences. And I really like it because I get to work on software and hardware at the same time. I'm definitely a software person as well, but like I always prefer to be working with the two of them in some way. So yeah, I jumped at the chance of getting this set up. So I'm really looking forward to seeing what everyone has to show us. Cool. Thank you.
Hey everyone, I'm Nikhil, and well, I've been tinkering with hardware all my life, but incidentally, like all the others, my day job is also software. So I don't know why I got into software, because I was always interested in hardware. I mean, I started taking things apart before I learned to read. So yeah, but anyway, my day job is software. I work on all sorts of things, DevOps, cloud, big data, stuff like that. And yeah, and on the side, I love doing something or the other with microcontrollers. That's about it. The one small claim to fame that I have is that I wrote the software, the official software for the Raspberry Pi Pico, which installs the SDK on Windows. So so if that doesn't work out for you, that's on me. But yeah, I, but yeah, that's the sort of thing I like to do, and I will probably be doing a bit of a demo a bit later. Yeah, thanks everyone, and it's lovely to see so many people here.
Awesome. Yeah. So that's a bit about us. Yeah, as you've heard, all in the software space, but very passionate about hardware. And that's kind of how the group came to be. So essentially, we believe and still believe that there is a community for this in Brighton. The amount of conversations we have with people that want to combine hardware and software, work in the software space, but don't really have an outlet for the hardware side of things. Passionate tinkerers and have all kinds of crazy side projects going on. I think Chetan was talking about a beer vending machine or something the other day, and just in the crowd. Yeah, so like there's all kinds of weird and wonderful things in the best possible way, and that's kind of our belief, is that if the four of us on some level have that desire to output that, there will be others in Brighton and further afield that want to do the same. So that's essentially how the group started. And yeah, that's how we all ended up here. The group is ultimately the only kind of, I don't want to use the word rule, the only kind of thing is that it has to have some kind of hardware element to it. There are lots of software groups in Brighton, all a lot of them through the wonderful Silicon Brighton, which we'll mention later on. But as long as it has a hardware element, then it's welcome here. It doesn't matter how early stages it is or how advanced it is. Yeah, it's welcome here, basically. This is a very random slide, I will admit that. This is my target audience slide, but I had a very generic corporate target with people on it, and I was like, that is not fun. That is not what I'm doing in my evenings. So I found this random project. It's actually a cool project. It's a Czech guy. He created this, and when you put your thumb over it, it reads your heart rate, and then it pulses along with your heart rate. I don't know why I chose this, to be honest. I guess my thinking was that it's, as long as you love hardware, that's a very loose connection. I was trying to keep it fun. I mean, it's a damn sight better than the corporate, here's a target, you're our target audience. But yeah, basically, our target audience is anyone in Brighton, all levels, we have that amongst the organizers as well, compared to John, for example. My level of expertise is much lower, but I think that's what we're after. We're after everyone. There's no question too silly. There's no, if you want to collaborate on something that's very advanced, then it's all welcome, basically. Yeah, that's my silly slide done. I also was very aware that I hadn't done a transition in the slideshow, and it's not really a slideshow until there's a transition. So this is a little bit on the format. So we do have long-term goals for this group in terms of building it out into workshops and hackathons, and we already have kind of guest speakers kind of queuing up, and we have another date in the pipeline, which we'll talk about later for the next event. So it's worth mentioning here as well that we are very open to collaboration at this point. So if you do have something that you want to show, we've already had lots of different ideas bouncing around tonight. So please come and approach one of us, because we are, we want to try and make this as community based as possible. So with the show and tells, We have 2 of the founders showing something tonight, but it's very much throwing it out to yourselves, and we want to learn about the projects that you're doing. We want to help you with them. You know, we want to kind of be involved and be part of that community, as well as trying to create a space for the community. So that's just a very brief kind of slide on, you know, the general formats. And that's it, really. Yeah, that's kind of how we ended up here, a little bit about us and what we're aiming to do. I'm trying to keep it as brief as possible, because in my mind, this is kind of the boring bit. This is the fun stuff. You know, we have a lot of cool stuff lined up tonight. So yeah, I'm going to pass it over to Charlie now, who's going to speak a little bit about Silicon Brighton.
I'm going to, thank you very much. Yeah, another round of applause for Mike. I'm just going to pass over very quickly to Rowan, who's very kindly hosting us here at Eagle Labs tonight. There you go.
Perfect. Yeah, I'll keep it as brief as possible. So yeah, we're in Eagle Labs in Brighton. So for those of you who don't know, we are a national network of business incubators and co-working spaces. So this is a former Barclays branch, but now it's been converted into a co-working space. So this is usually our co-working space during the day, and then we also a business incubator, which differentiates us from a lot of the other co-working spaces. So if you've got a business or even a business idea, or you're building a product and you want support for that, then we've got a wealth of lots of different programs and opportunities to help that along the way, really. And that can be from idea stage all the way through to exit. So if you've even got a business that you're looking to exit, lots of different ways on that stage we can help you. And then we got the digital growth grant last year. So there's lots of initiatives for growing digital things within the space, as well as hardware stuff as well. So yeah, lots of things are mentioned on here. You can scan the QR code on this one or the back, or just come up to me and ask me. But again, we're in an event space here, and we're always looking to collaborate. So we're collaborating with Silicon on lots of different meetups within the tech space. And if you've got an idea like these guys, and you're looking to have a little home for it, or you want to pitch us an idea for an event, then yeah, let us know. But cool question. We have, well, yeah, unfortunately, if you guys had come maybe a year earlier and done this here, we did have a maker space. All of our Eagle Labs used to have maker spaces, but as we've evolved, we have developed a little development lounge in this. We do have a couple of 3D printers, so do pop your head through this room here to the development lounge and have a look if you're interested. And we used to have a laser cutter. It was always, I always used to kind of describe it as a DT workshop on steroids, but unfortunately, it's kind of gone out. But we can also connect you with Build Brighton. So if you don't know about Build Brighton, the community makerspace, we donated them a lot of our equipment, so the laser cutter, a lot of the 3D printers and that, so we can always refer you over there if you're looking to tinker around with that kind of tech. But yeah, a little bit of housekeeping. If there's a fire alarm, I think just out the front to the left outside the Joker, and then toilets just down these stairs to the left. But other than that, yeah, really great to have you in house, and if you've got any questions, come and see me. I'll pass you back over to Charlie.
Thank you, Ro. Thank you so much, mate. Hello, yes, my name's Charlie. I have the great pleasure of working in events and community engagement for Silicon Brighton. We are the hosts of Brighton and Hove's Tech Sector, and we support over 30 different meetup groups across the city, none of which before have done anything to do with hardware. So it's a real pleasure to be starting this group up with you guys and be moving into a new space. Like we're so excited. We're gonna have to update that and get you guys on there as well. You are? No, you're not. Sorry, we're catching up. We're catching up with ourselves. But yeah, so we have the great pleasure of supporting over 30 different meetup groups across the city, and all of our groups, all of our events are free to join, available to people at all levels, and they're hybrid. So obviously you're all here in the room with us tonight, but there's also a live stream on YouTube where you can watch at home, and we'll post a video afterwards if you want to rewatch everything and anything that we go through this evening. None of the work that we do would be possible without the help of our fantastic supporters, all of whom you can see here. And we need you. We need more help with speaking at events, volunteering at events, and help with supporters as well. So perhaps if you'd be interested in coming talking at an event, or being more involved with a meetup group, or there's a business who you know who might be interested in supporting us, please come and have a chat with myself or my colleague Steve, who's here tonight. And these are our values, which we look to, I'll let you read through these whilst I'm talking, but we look to uphold these in all of the events and all of the work that we do. And if you feel at any point that these aren't being upheld, please again, do just come and talk to us and let us know. You can follow our socials to stay updated with all of the events that we've got going on Instagram, LinkedIn, Twitter /X, and TikTok, all of which are at Silicon Brighton. And we are in the middle of a fantastic, everyone knows that May is the best time in Brighton, but for many reasons, but we're partnering with Brighton Fringe for the first time this year, which is such a pleasure. We're working with the festival to introduce like a creative aspect to all of the events that we have throughout the month, which we're actually going to jump into in a minute here. If you scan this QR code, it'll take you to the Fringe website and use the discount code Silicon, you'll get a discount at the checkout. I feel like I don't need to tell you, but go to see some Fringe shows. They're just absolutely fantastic. And there's over 700 Fringe events throughout the month of May. So there's something for everybody. If you want to come and see another event that we're doing soon, scan this QR code where you'll be taken to our events page. We are back here actually next week for Brighton R on the 23rd of May. And we've also got Brighton Cloud and Tech Jumpstart next week as well. And if you scan this QR code, you'll be able to join our Slack community to stay a part of the conversation and network and chat with people in between sessions, in between events, and also to find out about other things that are going on that you might not hear about otherwise. Finally, please scan this QR code, which will take you to the meetup page for Breaking Breadboards, and you'll be notified then every time that the next event gets posted. We do have a date in the diary for the next one, which is the 31st of July, for all of you to put down into your calendars now. And that's me. Thank you so much. I'm going to pass over to Duncan, who's going to do a demo for us, a creative demo for us on how to use AI to make art. This is our creative part of the evening before we get into all of the show and tells. So thank you so much. Yeah, is that cool?
Hello. Let me just come over here. My name's Duncan. I'm a TV editor of 30 odd years. And last year I found AI. And I'm going to take you through some of the things that I've found with it, but a very brief journey. Normally I talk a lot more about it. I'm definitely been involved with Silicon Brighton before, and I've done some demonstrations of how you can use this stuff. But tonight, as it's Fringe, we're going to have some fun together to start this event off this evening. We're going to look into a program called Suno, which is, you may have heard of, the latest music making program in AI. It's quite incredible. You'll find it out. But we're going to do a complete interactive session here. In between all of us, we're going to write some lyrics and we're going to make some music. Okay, and it won't take very long, and it's a very quick demonstration. So the way that we do this, you've probably all come across ChatGPT, and this is something that you can all do at home as well. These are free models that we're working on here, and you can start to use this. So this is 3.5. You can see up here, this one is free for you to do this. It will work at home. The only reason I'm using version 4 is because after we've finished our music creation, I'm going to make an album cover for it as well. And you're going to see all that happen in these few minutes. So I kind of need a microphone stand. These robot things would be quite good for that. It would just hold it quite nicely, wouldn't it? Can I use that instead? Is it? Just
put that on just there. That's perfect. I'm not just yet. Can I just do a little bit of that? Cheers. Excuse me, guys.
Can you all hear me? So yeah, okay, I'm going to do it. Can you hear me? Hear me? Hear me? Can you hear me? Hear me? Hear me? 1 2 1 2 1 2. Okay, back in the room. Okay, so this is where it gets interactive, everybody. We're going to write a song. Okay, and so I'm going to just put it out there. And I said I'd hassle this person here first of all. What's our song going to be about? Got a bit of hum going on here. Shall I bring it up a bit closer? Okay. What's your name? Richard. Okay, so Richard is having a 35th anniversary. And don't worry about spelling. If you've got issues with your spelling and stuff like that, I'm going to intentionally spell things wrongly here and leave them broken. It doesn't matter. AI looks at the context of how you look at things, not how you spell. It doesn't really care. So Richard having an anniversary, 35-year anniversary, with your partner in a very woke way called Sue. Thank you very much. With his partner, Sue. Okay. His partner, Sue. Okay. Where's this set? Anybody? Anybody at all? Just shout. Anybody put your hand up or anything, or you want to talk? Where's this set? You, sir. International Space Station. Excellent. International Space Station. Like it. Okay. What year is it at the back there? What year? 2035. 2035. Okay. 2035. Okay. Tell her, what about, what's one of the most important things in their lives? Would you say? Golf. They love golf. They love golf. They love golf. Okay. And where did they meet? You, sir. Where did they meet? At Brighton Pier. Met at Brighton Pier. Met at Brighton Pier. Brighton Pier. Okay. And who else is at the back of there? That chap over there. What kind of pets do they have? 2 cats. Anything more exotic? And a lion. 2 cats and a lion. 3 cats. 2 cats and a lion. Okay, so we have 2 cats and a lion. And then I think just for sort of one last sort of little bit, how do they like to dress? At the very back there, so I can see you at the back. How do they like to dress? Are they conservative? Are they naked? Do they wear top hats and tails or ball gowns? How do they like to dress? Flamingo feathers. Okay. And they wear flamingo feathers whilst eating. What do they like to eat? And you at the back of there. Pasta. Okay. Pasta. How about space pasta? Space pasta. Huh? Freeze-dried pasta. Oh, hang on. What's going on here? Oh, hang on. We've got a connection issue. Hang on. Oh, hello. Is that this end? Hold on. Let's just reload this. Yep, let's copy and paste that very quickly. That's an unusual one. There we go. That's back again. No, we don't want to try that one. Here we go. Always tech issues, right? Oh, look at that. That's interesting. Okay, maybe it was too many for it. It didn't like the freeze-dried pasta. There we go. Eating pasta. Okay, so the pasta froze it. Pasta froze it. Okay, so I'm literally now just going to enter this, and it's going to come up with lyrics. I'm just going to literally put it in like this. I'm going to say, Richard having a 30 minutes with him. They love the at Brighton. So the first thing it's going to do is going to give us a picture, right? This is the first thing here. And I'm going to say, from here, generate me. And you see, I'm not going to leave the bad spelling. Generate 3 choruses. 3 choruses, 3 chorus and 2 verse of a song for me, of a song. There's your flamingos in space with your lions and your 2 cats. It's got that pretty much right, and we're on the space station. So there's your album cover for a start. I was going to come to the end, but it's done it now anyway. From here, and Sue is a flamingo, and Sue. Okay, Richard Lord International. Okay, you think Sue's a flamingo? Yes, I'm sorry about that. Richard and Sue aboard. You know. Okay, and here we're going to generate 3 versions. We're going to do 3 choruses and a verse of a song. Sure, I can help you with that. Okay, we've circled the stars just for you and me. 35 years, and still we dream across the cosmos. Love's like beams, together forever, or so it seems. Oh, Brighton Pier, where it all began. Laughter and love, our life's great plan. From earthly shores to stars above, every moment filled with our love. I mean, that's poetic, right? Okay, so that's just the start, right? Now we've got our lyrics, and now we've got our things going. We're going to move into this wonderful program. You can do this at home, I promise you. Go home and do this. If you've got anything you want to make up or you want to write things about people, just communicate with your family in songs from now on. I mean, whatever you want to do, right? So we go over to Suno. You can see here I've been doing stuff before. I had a group of people on here working. I'm going to copy these lyrics, first of all. I'm just literally going to copy and paste them like this, as we always do. And over on Suno, you'll see I've generated designs before. We have this option over here on the left-hand side of the screen, which says create. We can go into create mode. We can go into custom mode, which we're going to do here. And you'll see there's a little box here for my lyrics. I'm literally going to paste the lyrics into here. You can see them here. It's gone up to the end. We only get 2 minutes on this. You have to extend on the ends. We're not going to go past 2 minutes and do the extensions. We're just going to come up with the first 2 minutes of the song, and we'll see what we get out of it. If Richard particularly wants it, we can talk about a commission afterwards. I'm sure that's fine, you know. And on Silicon Brighton, you can have it for free. So this is where the fun part comes in. I'm going to go around the room, okay, before we hear anything. And we're going to get a few different styles. I'm going to show you quite amazingly how this is. And then I think what we'll do is we'll get a few proper ones, and then we're going to have a stupid one. We're going to put a load of images of ideas together and see what we get. Sometimes it comes out with amazing things. Sometimes it doesn't. So a start of music. So at the back there, start of music. Cat singing. How would that be? Like sort of feline opera or something? How would you describe that?
That's more like a high-pitched.
Cats singing Christmas songs. Cats singing, in sort of high-pitched voices. So like Disney mice or something like that. Okay, so children's cat songs, children's cats or something. Top Cat. Alvin and the Chipmunks. Okay. I'm not sure if it'll go. Copyright's an issue, so we'll say children's fun comical. How about something like that? Does that work for you? That's one. All right. You at the back there, sir. Baroque. Okay. So I'll put a Baroque in there. Okay, we have a bit of Baroque. At the very back over there. Country. Just country? Okay, country. Okay. Bluegrass. And I'm just going to sort of jump over these quickly for you all. And you can see it's starting to iterate now. It's coming down. One over here, sir. Klingon opera. Okay. If we've got bluegrass Klingon opera, that might be quite interesting. In fact, I'm going to leave that because that looks quite interesting. Okay, so we've now got some versions of this. And then let's just do one mashup completely. So just go around the room quickly. You sir, in the middle there? Techno. To 80s techno, 90s? 80s. Okay. Sorry? Barbershop quartet. Okay. Hang on. Barbershop quartet. Okay. Anyone else at the back there? Reggae. He likes a bit of reggae, this one. I'll give you that already. And then, which this is just, I'm just mashing this together for the fun of it. Anyone else down the front here? Anyone else at the back there? You? Anyone? Got one? Punk? All right, punk. Okay, so we go. So let's go from the top. What was the first one we went was hang on, here we go. Sorry, here we go. So the first one was, where are we? Has it generated? It has done. Here we go, by the way around. Right, so the first one was, we had, what was the first one? Classical. Was it the Cats one? Here we go, children's fun comical. There we go, right. Oh, we got sound?
Just you and me. 35 years and still we dream.
It's got children's comical.
I
mean, I can't stand it personally. I think it's awful. And we're going to move on. This is more like, now children, if you all take your seats and have the parents.
We shackled the stars, just you and me.
Not bad, you know? I could use this somewhere online.
35 years and
So we move on.
dream.
This, right? So we go on to, what's next? Baroque.
We've circled the stars, just you and me. 35 years and still we dream. Across the cosmos where love's light.
Not bad. Okay, we go for our second Baroque. 6 days. It's more relaxing, I think, for some. Very nice. Sometimes they get musical, just musical. But listen to that piano, I mean, right? I mean, how much would that person cost to employ to be able to play like that? And how long would it take? This one sounds more instrumental. It's gone to the country, because I always like to the country. Who chose country?
Together forever, or so it seems. On Brighton Pier, where all begins. Laughter and the last months were alive.
Like it. I've gone to the second country track. Just in case. That's very country.
Just you and me. 35
My name's Berber.
years and still we
You gotta make some music.
Across the cosmos where love's like this. together forever, so it seems.
That's a good one.
On Brighton Pier,
not bad.
it all began.
That's not bad. I'm gonna put a like on that one. That's big. I'll give you this one. She'll try 35 years will just be a flash of, just gone. Bluegrass. You say bluegrass Spring Opera.
Of we circle stars, just you and me.
Not enough Klingon in it.
35 years, and still we
voice.
dream.
Still we dream.
Across the
voice.
cosmos, where love's light beams, together forever, or so it seems.
Round of applause for that one. That was a good one.
Circle the stars, just you and me. 35 years, and still we dream. Across the cosmos, where love's light beams, together forever, so it seems.
What was the next one? Techno 80s, barbershop quartet, reggae punk. Okay.
Oh, we circle the stars, just you
That's a barbershop quartet. Quartet. I'm hearing techno. Not hearing much reggae. It's not bad though. And here we go to our second choice.
Circle the stars.
Oh, we did all this before these. That's a bit more.
35 years and still we
See where
dream.
this goes.
On Brighton Pier, where it all began. Circle the stars, just you and me. 35 years.
Come for a quick rave in the house. I mean, we turn it up every now and then. We go, hey, start out to the anniversary. Bring it on, 35 years. And then one more to go after that.
We've circled the stars, just you
That's
and
very barbershop, isn't it? One with
35
a haircut.
years, and still we
But I think for me, the hands down winner
cross the cosmos.
has surely got to be
circled the stars,
Thomsen. And as we let this play out, I would say that's my presentation for the Brits this time. This is AI, just making it like that. You can all do this at home. You can use 3.5. You can have some fun. The lyrics will generate for themselves. And you can sit and go down the rabbit holes that I go down with this software, and it's a lot of fun. You can use it to put to your music. It's copyright usable. You can create films with it. You can put it as tracks, whatever you want. This is an amazing tool. And it's just part of the stuff that's emerging now into this world. Tech will come along with it. I'm sure we'll be able to plug in instruments soon and play with it. Even maybe machines and stuff like that, we'll be able to conduct. Who knows where it's going to go, but it's going to go somewhere. So effectively, that's AI and music and how we do it. That's it. And well done, you guys, for coming up with such amazing ideas and lyrics. Thank you, Richard. Yeah, there you go. She's going to be very happy with you.
Brilliant. Duncan, thank you so much, mate. I'll take that off you. And John, are you starting us off with the first show and tell? Okay, great. Right. Let me put this down and get you clipped up then.
How would you know where to put the mic? So let me just truck my Mac in, because I have a few slides to talk about where this is all coming from and what I'm doing. So hopefully, oh, that actually works. So yes, I'm going to talk about some robots and these incredible things in the big front there. And I started my journey into robots, or my journey again into robots about 5 or 6 years ago. And I started with that hexapod. And like most of my robots, the first thing I did was ditch the software, mainly because it only wanted to use Windows and these things that I just don't do. So I ditched that and rewrote everything in ROS 1. It had a problem though, because everything had to run on a Raspberry Pi on the robot. And I quickly ran out of power. So all the calculations of where those legs are and all the angles of those legs, that used processor power, which I couldn't then use to when I got back into looking at that more recently, therefore, I thought, how can I get away from this problem of this big Raspberry? Because I can't go out and buy a bigger Raspberry Pi. They don't ship them anymore. So what I wanted to do was see if I could actually do some distributed computing and actually build robots that have lots of computers in them. And that's actually what I'm playing with and what these things are actually doing. So I actually have a operating system that's based around a Raspberry Pi that's doing high-level control, plus microcontrollers that actually do all the low-level controlling of the servos and the bits and the worrying about angles and the worry about comms. And so it works like that. So, and I use a open source framework called the Robot Operating System version 2 and something called MicroROS, which is what actually runs on Raspberry Pi Picos and some other technologies as well. So, and there's also something called FreeRTOS, which is also quite useful. So let me tell you, I'm quickly going to tell you a little bit about who I am, where I'm coming from, and then talk a little bit more about these robots, the architecture for those robots, and then we'll get into actually making them move, hopefully, or making one of them move anyway. So, yes, as I told you earlier, I didn't really start this journey of my world actually being a robot engineer. I started in the wonderful world of corporate, helping our companies understand how to get their IT department to actually do what their business do and connecting the two strategies together so they actually could work together. After no one actually ever read these things and all of these various reports I've done for various companies, I gave up with that and I decided to play around with robots instead, and this was a much more exciting place to be. So I managed to make my hobby my job. Oh, look, lightsabers. In 2022, I started this journey down and started making a lot less money than I used to in the corporate world, but having an awful lot more fun and helping people actually write code for these sorts of devices. And I have a variety of courses out there on Udemy and also build a whole load of stuff and publish every week on YouTube of my journeys. Some of them are success. I did a recent good presentation around all of the failures and all the things that don't work, because lots of things don't work. Normally connectors. I break connectors a lot. But yeah, and occasionally I do some consulting, often with Americans for some reason. But really I want to talk about the robot operating system and how that is going to help with these robots. And the robot operating system is a massive framework. It really helps me a lot with comms and communications and models and how all of my parts can come together. But it can also do things like the IK and FK algorithms to actually work out where your robots are in space and what their movements are, odometry, which is, and all of this stuff, mapping controls, that's all fun stuff. But actually, we'll talk about some of the basic stuff today. Because the other bit of it I want to do is then micro-ROS. So how can I distribute? How can I have bits of my world controlled on different computers, all interfacing and talking together? So the first robot I built on this was actually a video turntable. And I needed that for YouTube to show stuff and make it look something interesting. Is a turntable a robot? Well, I think it is, because it's got a joint, and that joint moves. It's a stepper motor in this case. And I can work out its 0 position because I have a Hall sensor on that. So I know when it's at 0, so I can actually tell it to move at various speeds onto various angles. And it is entirely a robot. I then jumped into a complete droid. So this is DDD, my DIY dev droid. I would have brought him tonight, but he's kind of fragile because he actually only has a breadboard on top and lots of wires just plugged in. So he tends to break a lot, and he wanders around. He's actually a bit more advanced now. He does mapping as well, and some planning and navigation. But it's the same architecture. I've got a Raspberry Pi Pico that controls low-level stuff, and actually high-level stuff is on the Raspberry Pi. For Christmas, I'd had some fun. I built a robot's head. This is Santa. Santa's servos are controlled by a Raspberry Pi Pico. You begin to sort of repetition here. Its eyes are controlled by the Raspberry Pi Pico as well. And then the Raspberry Pi is actually doing camera, so it's actually doing the video processing stuff. The stuff I couldn't do on that robot I started talking about. So it can actually do face tracking and face detection. So when it sees me, it wanders around and keeps looking at me in really terrifying ways, and its eyes turn blue to tell me that I'm a good boy. So all of these robots all have the same architecture. On the high-level stuff, I've bunged on a Raspberry Pi, where I've got nice Linux operating system and I can do multitasking. And the low-level control of all of those horrible hardware bits that need you to actually have accurate timing and accurate protocols, etc., I've done on a microcontroller, and they communicate together. And they do that using the wonderful world of ROS, micro-ROS, and FreeRTOS. So what really is on that microcontroller then? Well, really it's a bunch of, it relies on FreeRTOS, which is a real-time operating system. So I'm able to conjure up the small amount of processor power that's got into various tasks which actually operate the bits of that world. So we have a comms, a micro-ROS bridge out to the world of ROS so that I can talk about things. Then the motor controllers is a separate task, the sensors, etc. So these then communicate in the world of publishing subscribe. So it publishes what's going on, subscribes to commands, and handles the messages. There are some more advanced bits of ROS that I don't do right now, but I might do at some point in the future. So with that, I'm going to hopefully try and demo that with one of these robots. And these are 6 degrees of freedom robot arms. They use bus servos. Bus servos are great, not least of which because there's less connections because you can actually chain them. But they're also great because you actually get feedback of where the servo actually is. So it's not just set it to an angle and hope. Actually, I can read what its angle is at any one time. And these are Highwonder products. This is a Highwonder XARM 1S. And as with all Highwonder products that I've so far bought, I've ditched the software. And what we've got there is then a Raspberry Pi Pico, which is sitting there doing the communication out to ROS over onto my Raspberry Pi and to the servos via serial comms. So what I'm going to demo is, first of all, to be able to publish where all of those 6 servos are, what angle they're currently at, into the world of ROS. And that way we can actually visualize it, and it can show me a visual representation of that. And then I'm going to subscribe to a message which is going to tell me where I want to move all of the joints to. And that's then going to go over to this lovely model, which hopefully is going to work beautifully on the Pi to actually display this, and some wonderful command scripts that I'm going to run. That's the hope. Now, I will say that in the grand scheme of robot building and robot design, we're only halfway through what I'm going to show you, because we start by hardware. That's easy if you've got a kit. We then want some models of what this robot looks like inside the computer, inside the world of ROS, and indeed also in the software that's there so it can measure angles and understands where it is. And some joints, so we can publish the position of the joints and actually receive commands for those joints. that isn't enough, actually. We need to then go into be able to control the robot at robot level. So actually know exactly what the position of the end of the pinchers are. Where is that in space, in angles, etc. That's the next step. I haven't got that one in this robot. Some of my other stuff does that, but not that. And then you get into planning. Can we actually go and pick something up and move off with it? And the planning operation. But today, it's just going to be joints. So let's bravely try the world of the planning and go into the demo and see if that will actually work for me. My stuff is all online, all as Dr. John EA. I'm on all the social channels. Best place to find all the stuff is on YouTube, and it's cool, I think. So let me switch beautifully to, it's working. So here we have a model of that robot. Here we have a script up here. So I'm going to write some Python, which is going to basically keep sending instructions to the robot to tell it where each one of those 6 servos should be and what the angle is. It's instructing them that it should make this move in about a second. I could take it to do it faster, I could do it slower. Doing it faster is quite risky because sometimes it jumps off the table. Yeah, and with any luck, you can notice that that is pretty much following where it's going, because it is that microcontroller sitting back there is actually publishing the position of every one of those angles 10 times a second, or if it's 10 times a second. That's going over to that Raspberry Pi, and the Pi is able to draw it as a lovely little robot model, and we get a moving, sexy robot. So, there we go. Thank you very much. Do we, look, I did that pretty quick. We got time for questions if you want, before we move on to the next exciting demo.
So why do you hide it on the Pi? Because you're not using Pi GPIO. I mean, to my mind, especially now, the Pi used to be cheap compute. Now there's a lot of other ways of getting cheap compute. Because not using the GPIO on the Pi, it's just compute. So why use the Pi?
I'm using the Pi because I had one on the shelf and it's an easy thing, and it's and it has a binary install on Ubuntu for robot operating system, which saves a lot of time, as the building robot operating system from source is hard, to say the least.
Building anything from source always ends up being 3 days of black hole, doesn't it?
Indeed. So Ubuntu 2004 has robot operating system binary.
The visualization on the screen, is that a natural part of ROS, or is that another? Can you talk a little bit about?
Yeah, sure. So this is a ROS application called RViz, which is basically designed to be a visualization of environments and robots. So when you start it up, it knows absolutely nothing. All it knows is to listen to some particular message channels. And from those message channels, something else has broadcast a description of the robot. And then it knows to listen to another broadcast, which is broadcasting and telling it what the description of where all of those angles are. In fact, if I am careful, and if I can do this by looking backwards, there in here is, let's have a look at tree. there is a description of the world, the base link, which is basically the connection between the world and the robot, link 6, link 5, all the way up. So going up this chain, right the way through the robot, basically. And it knows the location, so it knows the location of every point on the graph.
Nice, yeah, thank you. I have a trivial side question. Have you tried to pick anything up with it yet? And how did that go?
Yeah, yes, but not controlling it the way that it's been controlled tonight. So you can when I first put it together, I played around a bit, just driving directly from my Mac into with Python. I also played around with the PlayStation 3 controller that they give you to plug straight into it. That was the most boring thing I had ever done. It was terrible. It felt like it was a dead robot. I thought, what have I done buying this? But then when I actually started running straight from my Mac with Python to control it, actually it became almost alive.
Nice, nice. Any other questions? That's it.
Thank you very much.
Yeah, okay. Yeah, that's live. Yeah, just give me. I think a bit too high. Yeah.
Just there. There you go.
Yeah. Right. Just give me a minute to set up everything.
What's going on?
I'm trying to get it to work. It's just
Strange.
yeah, that's strange.
Oh no, hold on.
Did it work?
I'm not crazy, right? That was working for a second. Okay. Give me a second here. Is there a USB-C port for display?
Yeah. We can use this one.
Let's see. If this doesn't work, then
Yeah, then we'll go through the adapter. Yeah. Okay.
Oh, it would just be too easy, wouldn't it?
Yeah, we can just
Let's try it.
Yeah, let's try the USB Type-C. Yeah, it's on this side, I think. Yeah, here.
Thank you.
Yeah, okay.
There we go.
Cool, excellent. Right. Hi. So I am Nikhil. I introduced myself earlier. And I'm going to be talking about programming microcontrollers because that's just, like I said, I'm a software guy, and that's the sort of thing that I like doing. Well, to begin with, like I said earlier in my introduction, I actually prefer programming in C and C++ and that sort of thing. But I understand that that's not the environment for everyone, right? Okay, before I proceed, does everyone know what a microcontroller is, or does somebody need like a 30-second intro? Okay. Is there anybody here who has like tried programming microcontrollers but gave up because it was just not, just yeah, I'm sure that's you. Anyway, whether you gave up or not, it's a different thing. It's just another tool in your arsenal, essentially. You can, of course, program microcontrollers in low-level languages, C, C++, assembly, whatever you want. And of course, there are a ton of things already out there which are super easy to use. Arduino makes it very easy to use, and now there's a big ecosystem around Arduino. There are things like Platform.io, which are along the same vein. They kind of make a lot of microcontrollers and boards and things like that super easy to use. However, all of these essentially require you to install some stuff. So what I'm going to be talking about today is actually programming some microcontrollers without having to install anything on your computer except from, well, a regular web browser. So let's dive into that. I have a couple of demos here. Let me just introduce you to the hardware first. I have a bunch of these little things. These are Microbits, BBC Microbits. So yeah, they've been designed in the UK. Not manufactured here, but yeah, they've been designed here for sure. And they're little. The chip on them, it's on these ones. It's a Nordic NRF51. If somebody knows the details about that, there's a new version of this. It's called the Microbit 2 that has a Nordic NRF52, which is a bit more powerful. It has a bunch of more things on it. The other microcontroller that I have here today, this one is called Espruino Pixel.js. This is really interesting because you can program this one in JavaScript. So I think that opens it up to a lot more people all of a sudden. The thing with something like Microbit is that you can program it in JavaScript, Python, whatever, but that stuff is actually compiled and to machine code, and then you load it on here. This thing is really cool because the JavaScript is actually interpreted on the chip. So it's not compiled beforehand. The JavaScript interpreter is actually running on the chip itself. Yeah, so all of these can be programmed without actually needing to install anything beforehand. So yeah, let me just get into the demo. Yeah, so this is the online editor for Microbit. I chose the Python one. There's a JavaScript version as well, if you choose to do that. What I've got actually is that I've got one Microbit connected right here to my computer, and I've got another Microbit which is connected to a battery pack here. It's just a quick little demo that I chose randomly. And what I'm going to be doing is that it's just a few lines of Python, and so this one is going to be just transmitting some data, and because NRF51 they can do Bluetooth, but they can also do like raw 2.4 gigahertz communications. So you can build your own formats on top of that, which is not Bluetooth. And here's a receiver bit. So all the receiver is going to do is just going to receive data from the other one and just throw it out onto the screen. That's all that there is to it. I mean, I just want to demo like something that it's incredibly simple to achieve wireless communication with something like this, and you don't even install anything on your computer for it. So I'm just going to turn this one on, and if I program this one, so it shows me the option to choose which one I want to program. I just connected it over USB. I didn't even have to install any drivers or anything. And yeah, there's a serial console. And when I move this one around, If I just leave it there, you'll see the numbers stay the same. It's because that's the accelerometer. If I pick it up, I mean, it change. Just a demo to show that, I mean, it's actually reading the data from here. If I turn it off, yeah, it just goes silent. So yeah, so that's one of the demos. The next thing, so with the microbit, I mean, the thing is that when you're programming it with the computer, you have to connect it to the cable. So you want to go one step further with this Espruino. But by the way, I mean, this is also like it's designed in the UK. It's there's this guy Gordon who basically designed all of it and wrote the entire software stack basically for almost from scratch. So it's really cool. I just programmed it with like a demo clock application. You can see there's a little clock showing on it. It's just powered by a coin cell. So if I go into the Espruino IDE, which is again, it's just on their website. It's espruino.com/IDE. So this is the clock application. So instead, if I pick up another application, let's say, yeah, this is another, it's just a sample application on their website. I just copy the code here, and I will just go ahead and paste it in here. And I will click this button to program it. Okay, it's going to connect. Okay. I think, yeah. Sorry? Oh, okay. Oh, yeah. Yeah. Okay. Right. Yeah. So this is, that just programmed it right away, and the JavaScript is actually being executed right on the microcontroller. I didn't even have to connect it with a cable to my computer or anything. It just did it over Bluetooth. I didn't even have to like pair it as such. It does this thing called web Bluetooth, which is something that works at the web browser level. And yeah, I programmed a bunch of these microbits earlier. It's like a simple voting kind of a demo. If I click one of the buttons, one of the microbits, hopefully you should see one of the numbers increment. Yeah, that's a 1 there, and it says the second number. So this guy voted for 2. So if this guy votes for 2 as well, there's a 2 over there. And yeah, so I mean, it's again, it's just a very simple demo about how you can actually communicate across microcontroller families, ecosystems, and while still being super easy to program. I didn't install any software at all on my computer to program all of these. So yeah, the intent was just to show how easy it can be these days, which was certainly not true maybe 10 years ago. Yeah, so that is the demo. Any questions? Micro.
Any questions?
Yeah, I think the person at the back. Yeah.
Thank you. Right.
Anyone? No, I don't think there is a question. Oh, sorry.
So if you didn't install anything, because I have no experience with microbits, how did you sync them? How are they talking between themselves?
Between themselves? Yeah, so that's the thing that I was talking about earlier, that they have the chip which is normally used for Bluetooth, NRF51, but the chip is basically, it's just a 2.4 gigahertz transceiver. So you can program it to do any protocol. So what these guys have done is that they've created their own protocol stack for it, which kind of can do the communication between the microbits without actually like doing any kind of pairing or anything. If I go back to that program, they've just created this library called radio. I just say radio.config, and there's a group number there. So yeah, and if the other microbit is also on the on the same group number, it just talks. It's not supposed to be scalable. It's not supposed to be secure. It's not supposed to be anything. These things are primarily meant for use in classrooms, but they're really cool. So I think this is it's just an easy way to set up wireless communication without having to think about Bluetooth pairing and Mac IDs and things like that.
Nice. Yeah. Thank you.
Sure. Anybody else?
So what is, in your opinion, because you seem to be like very like into it, what's the best controller in the sense of price versus features?
Well, what's best will really depend on what you want to do with it. We do have a lot of controllers these days. Raspberry Pi Pico, like Dr. John was talking about, is really good because it's at a very good price point. Of course, we have our ESP32, which is very powerful, and there's a bunch of variants of ESP32 now. We have the RISC-V version as well. Yeah, so I think it really depends on, I mean, do you need lots of I/O? What kind of I/O do you need? Like Pico can do, with the PIO, it can do some really fast I/O. It can even drive displays and whatnot. With ESP32, you have like the Wi-Fi built on the chip, which Pico does not have. It's on, and it's...
Okay, so let me maybe reframe it. So what's the cheapest controller which allows the Wi-Fi communication, which you can buy in bulk?
Probably ESP8266 would be the cheapest, yeah. It's not as powerful, but the Pico W is pretty cheap as well, yeah. Sure. All right. If that's all, then thank you very much.
Thank you, and thank you. So, I think we've got two more, Remy and Matt. Who would like to go first? Matt, you ready? Sweet, let's do it.
Okay, perfect. We good to go? Cool. So yeah, I've got a fairly simple project that I made probably 3 or 4 years ago now at this point. So my wife runs her own business. She sells her own products online. So she's an artist by trade, so she does watercolor paintings, makes them into designs, and then gets them made onto lots of different products like notebooks, tea towels, aprons, that sort of stuff. So as she was growing her business, she was really, sort of started slow as a little side project, but then went full time with it and wanted to see the sort of numbers going up and up and up. It was kind of a good motivator. So for her birthday one year, I basically made this little screen down here. So it's quite simple, just shows on the screen the sort of key metrics, I guess, for her business. So you've got things like the Etsy sales, her Shopify shop, Fair, which is like a wholesale marketplace, and Instagram followers. So just as a little demo, what we can maybe do, if someone has Instagram, if you can nip onto there and press follow, or alternatively, you could buy something on our website, but that's a nice easy way to do it. Either works. Okay. And basically what the screen does, it's just running with an e-ink screen on the front. Yeah, sure.
Thank you.
Cool. Everyone see it still? Yeah. Perfect. So it's quite simple. It's an e-ink screen on the front with a Raspberry Pi Pi 0W on the back. You can have a. Is that updated? Hey, perfect. So yeah, essentially, it's every minute it wakes up, checks the 4 different places, so Etsy, Fair, Instagram, and Shopify. Goes and grabs all the numbers just over the Wi-Fi. If there's an update, it basically then refreshes the screen. And the way that works, if I have this open, no, I don't have it on here, unfortunately. It basically draws an image using those numbers. So it's drawing text onto a screen using Python with a background image that's kind of pre-made with all of the graphics. And then sends that over to this screen, which is the Inky Watt, which this is quite simple, just has a Python library. You just feed it an image, and it will do that sort of classic e-ink refreshing. Benefit of that is it's super low power. It could run off a battery. Usually I just have it plugged in, but it'd probably run off a battery for a good couple of months, just sitting there doing its thing. Because once the screen is on, it uses basically no power unless you're updating it. Yeah, that's kind of an overview of it. I think that's kind of it, really. Any questions with it?
This works.
Yeah.
Mike, would you come here and grab this off me?
I'm interested in the housing that it's in.
Yes.
Can you talk a little bit about, do you have experience with the kind of fabrication side of things, or was it like, how was it kind of fitting it in there?
Yeah, so that was actually one of the bits that I kind of had to learn. So I actually went to Bill Brighton that was mentioned earlier and used their laser cutter. So essentially, maybe pick it up to make it a bit easier for people to see. The screen on the front is quite thin. What I've basically done, there's 3 bits of plywood on the front. The middle one is slightly smaller, so the screen kind of fits in that, and it's just sandwiched in between 3 bits of plywood, kind of sandwiching it in. And then just to give it a bit of room at the back, there's just plastic standoffs, some long screws, and then another one on the back. On the back, I just laser cut the logo, her logo on the back. So yeah, that was all done at Bill Brighton, just using the laser cutters. The way you do those, if you've not used them before, you basically create an image just with coloured lines, and you feed it into the laser cutter software, which has you just sort of tell it which colour is a cut, which colour is an engrave, and then what settings to use for that, like how fast to go, how powerful to turn the laser on, that sort of thing. So there was a bit of trial and error. I think there was one fire at one point where I turned it on a bit too much. But yeah, you sort of, once you've got the settings right, you can pretty much just press play and you just sort of watch it go, basically. This is a couple of years ago. I think I did take some videos, but it's a couple of years ago, so I probably have to go back and find those.
You got a video of the fire?
No.
Yeah, I'm just interested. It's because it looks great. It looks very like clean. Did you have the idea for how you wanted it to look off the bat? I think one of my kind of curses is getting far too into the technical bit, and then it looks ugly as hell, but it does what I want it to do.
Yeah.
Did you have that in mind from the start, or did you have the screen and then the kind of wood came separately? Or
yeah, I mean, I knew the screen was the main bit. I wanted it something big enough, so these are kind of the easy ones to work with. There is a like a smaller version of it, but I kind of wanted to show a few different bits. So all the dimensions kind of came from that screen, basically. And then at that point, wood was kind of the easiest thing to get hold of and use with the tools I had. I didn't really have the skills to make anything more, you know, custom, I guess. So the sort of laser cutting was quite an easy way to, you know, just measure things out, draw it in, you know, a sketch on the Mac, draw that out, and then just press play and, you know, have it manufactured, basically. Yeah, and I think the wood as well, like a lot of my wife's designs are quite, you know, they're sort of nature themed, essentially, like animal and nature themed. So, you know, for something that's going to be in her office, basically, the wood kind of fitted in fairly well. Yeah. Yeah, so that's kind of where that came from.
nice, yeah, thank you.
Did she like it? Yeah.
She did. Yeah, it actually it broke It broke about a year ago, and I just didn't at the time didn't have time to fix it. This actually got fixed on Monday after this, so this is kind of good impetus to do it. And as soon as I was like, as soon as I told her I was going to show it here, she was like, "Oh, does that mean I can have it back?" So yeah, it was there on the side. Originally, it was a little bit distracting because I had it updating the screen every minute, even when there was no numbers changing. So it was there constantly, and just sort of, you know, trying to figure out had something actually changed. Yeah, now it only does it when she gets a sale or a new follower, that sort of thing. Yeah.
You said about the power saving of the screens, and obviously eInk are great. Did you actually look at the Raspberry Pi and getting that to save power and truly go dormant, or not?
Not really. So with this one, it's the Zero, which I don't think you can do like a deep sleep, because it is just running PiOS, like Ubuntu or Debian, whichever it is. On the Pi, so I don't think you could put it into like a deep sleep mode, as far as I'm aware.
Not without some extra electronics, I think.
Yeah, probably not. This was quite sort of pre-Pico, that sort of thing. And given the time I had, I think I built this in a couple of days or something like that. So I didn't really have time to learn how to use Arduinos and get it working with eInk screens. That's partly why I chose the Pimeroni screen like this one, because it was very easy to get it working, and sort of came with a simulator version as well, so you can just see what it would do on a window before I actually had the hardware. Yeah.
Cool.
I suppose on that same note, did she appreciate the complexities of it? Because you've got 4 APIs to talk to there. And what often happens with these things is you go, "Oh, that screen looks great. Yeah, I'll buy one of those." "Oh, none of the libraries work properly with it."
Yeah.
"I'll throw it in the corner and get bored of it." And hopefully next time you take it out, either that doesn't exist anymore and you buy another one, or the libraries might work.
Yeah, so I think that was actually the issue with it, why it stopped working. The Etsy one, I think their API changed and it just didn't handle that well and just never updated. So yeah, that's now slightly better. It just zeroes it out now if there's a problem. But yeah, it was appreciated. I didn't tell her the complexities of it, but you know, yeah.
We're going to
jump onto the next one just because it's time.
Shall I hold on to this?
Yeah, that would be great.
I'll turn it off there, yeah?
Yes.
Cool. Okay, hi. My name's Remy, and I think at the beginning of the pandemic, I bought a Game Boy for myself for Christmas. Actually, just before the pandemic, bought myself a Game Boy, and in doing so, I realised that the screen was terrible. So I modded the Game Boy and put a new screen, and it's a fairly straightforward process. And then from that, I started buying more broken Game Boys to see if I could try and repair them. And over that period, I've managed to get through about 100 Game Boys, fixing them and then selling them on to other people. Definitely doesn't make anywhere near as much money as I make writing software, and I think that's the reason why we all write software, because the hardware is not as lucrative. But because of that, I keep on kind of tinkering with, like, are there some more interesting hacks that can be done with a Game Boy? And one of them is, I like the idea of, I like my 4-color screen, but I wanted like an arcade version. And it stemmed from this. I saw this guy on Reddit. He had made what he calls the Wood Boy. It's beautiful wooden enclosure for a Game Boy. And I wanted to make something like this as well. I'm quite happy with 2 buttons on my controller. I freak out when I see, like, you know, the 18 buttons. And I kind of know what's required to be able to do this. I know the Game Boy motherboard pretty well, or very well, and I know how it kind of breaks out into the display board that's inside the Game Boy. But the key part in this project is that it was done using a Game Boy consolizer. So that is, you buy a piece of kit and you plug your Game Boy into it, and then that plugs into the TV. So inside of his arcade is a monitor and this piece of kit. And the consolizer uses FPGA. So if you're not familiar with FPGA, I'm not going to do it very good justice, but it is very, very cool tech. It's reprogrammable hardware. Gaming projects like the Mister and the Analog Pocket both use FPGA inside them, but it's not cheap. I mean, £35 is not a lot of money, but I like my stuff really small and really cheap. And if the chip itself, which is £35, and that was the smallest one I could find, getting something to do a consolizer would cost a lot more. And I figured that actually the Pico has this PIO inside of it. It allows you to basically do bit banging on the microcontroller. It has multiple state machines that allows you to do kind of multiple bit banging on the microcontroller. And I figured that the CPU in the Pico was faster than the CPU in the Game Boy, so I had a good chance of like not writing great code and maybe it'll be okay. So, I mean, I actually started this project maybe 2 years ago using the Pico and VGA and trying to get the signal out because the SDK documentation for the Raspberry Pi has a VGA example. And I managed to get a single screen out of Tetris, but it wouldn't move and it didn't work, and I gave up on it and started again in February. And actually managed to pull in a few libraries to help me leapfrog some of the big complicated parts, like how to get an image onto the screen. I haven't got any links in my slides, but you can Google it, I guess. There's a project called the Pico DVI, which is an HDMI port, a bunch of resistors, the Pico, and a library that is using 2 of the PIO state machines to get an HDMI image out on an image onto an HDMI display. It's using DVI, and so my hardware kind of knowledge is thin, and I get away with what I get away with. HDMI, I think, is like a superset of DVI, so you can plug DVI into an HDMI port and it works. So that's what's happening there. This is my first attempt. So a couple of things to note actually here. This is a 5-volt machine, and this is not a 5-volt machine. This is a 3-volt machine. So I've just taken all the 5-volt signals and just shoved them straight in. And this is what I got. Is it? Oh, no. This is a video, apparently. There we go. This is what I got to start off with, which is, someone described it as Thanos trying to wipe away my project. And this is my monitor. So this is my monitor. It's coming out onto the coming through the HDMI. The Game Boy is playing, but you can, I mean, apart from the junk here, but also at the bottom, there's some vertical problems, like the whole screen is kind of bouncing off. The code, I'm going backwards and forwards here. This is, so most of the clever code is in the DVI package that I've just used. And I ultimately want to get a USB joystick in there as well. So I want to be able to plug that in. That's solved with Tiny USB, which is another package that kind of uses PIO to kind of bit bang the USB in. But this is all the code that I needed to get the display from the data from my Game Boy into the Pico. And it's actually twice as long as it needs to be because of a weird bug in the Game Boy. But I really like super succinct code, super tiny bits. And I mean, I'm not, this is saying wait for the H-sync to go high, then wait for it to go back low again, then take the 2 data lines and then just push it into a buffer that's sitting on the Pico. And then the Pico is running in a loop and kind of collecting that data, pushing it into a big array, and then its second core is taking that array and pushing it out to the HDMI. The reason why my image was so garbled, I think, is because there's a note in the DVI Pico project that says that the latency of wires from the actual DVI pins and the Pico have an actual effect. So the guy who created it has a PCB, so I got that made and soldered on the resistors to do all the work, and that sorted out my image. So I fixed the image. I also want to use USB joypads for controlling the Game Boy as well. And I didn't know much about how USB works. Like I said, there's this library called Tiny USB. It gets you most of the way, and I haven't fully solved it, but every USB joystick that I connected would announce itself, give me its description, its protocol, and everyone would be different. So the A button would be in a completely different place compared to another joystick. And the idea is you're supposed to be able to, it gives you the protocol, it describes the protocol, and then you're supposed to use the description of the protocol to work out how the gamepads work. But I figured I could just maybe take one joypad and know where all the buttons were, and I'd just make that one work to start off with. So this is a video of so actually I'll pause it. Oh God, no I won't. Sorry, I haven't used Keynote in a good 5 years. So this is a version of the project that has the DVI SoC, and I'm starting to get the joystick plugged in and connected to the HDMI. I've now finally got a set of voltage dividers using resistors. So my 5 volts is now going down to 3 volts for the signals from the Game Boy. Pretty sure that my Pico is already damaged at this point, or not this point, but like as of today. I'll touch on it when I maybe show you a demo. So the display signal's going into the breadboard, the voltage divider. That's then going into my Pico. I haven't plugged in the joystick now. That's some code, and there's audio, but I'm turning it on, and it's going to load the loading screen. What's also cool is that it's also on the Game Boy itself, so I've got the same display still connected, and it works. So I've got the display working. I think there was still one bug, but it was a bug to do with the Game Boy itself at this point. But I made some progress. My keyboard is here, and that's my work desk. So this is kind of sitting between my keyboard and Slack messages and like project work, and this sits here reminding me that I need to keep working on it. I got the joystick connecting and reading, but I could only get right and B to work, and right, B, and down. I don't think I could go backwards, and I couldn't jump. So DuckTales, you can start without using the start button. No, that didn't work. So this was where it was finally coming together. I was actually getting somewhere. I was seeing pieces working. It was working on the HDMI display. I had a joystick that was doing something, but it wasn't working perfectly. I then decided that I would break out all that wiry mess into my own PCB, and this is a breakout board that I made to take the input from the Game Boy and kind of organize it more logically, but also move the voltage divider from resistors down to a chip to shift the 5 volts down to 3 volts. And oh yeah, this was. You kind of pick chips based, or I pick chips based on their general description. If I get to this part of the data sheet, I don't know what I'm looking at most of the time. But when I put this all together, none of the display worked properly. It was doing weird things. I looked at the logic analyzer, and the voltages just weren't coming back down fast enough. They were just kind of rising and falling like a sine wave. It turns out that it was just quite slow, and the chip I needed was much, much faster. And I maybe should have just stuck with resistors to do the job. So I've got a new chip in there, a new voltage shifter, and I've got a new PCB design because all the connections are in a different place. I measured the Pico at 90 degrees. And this was, I think, Wednesday night last week. Yeah, I've got a habit of like just testing if things are okay by putting my fingers on it. And I felt like things were warm, particularly on the level shifter. And it was well and truly above 100 degrees centigrade. I burnt my finger to the point where it was like, it still hurt the next day. And I think what happened is I found that I'd missed I don't know if you've done PCB design, but every time I do PCB design, it turns up and I'm missing a trace, or every single time. So at this second board, I was missing a trace to get ground back round, and I think when I soldered it in, I'm pretty sure I soldered the ground in and then bridged just with a little bit of tin to VCC, and that I think was making the voltage shifter go absolutely batshit. I put a bit of alcohol IPA on it a couple of days ago just to test it, and it disappeared instantly. So I was like, okay, let's get rid of that, put a new one on. New one was fine, got rid of my bridge, started working. So, as of today, this project I started out 3 months ago, no, February, actually works. I got it working just like at 5:30, where the display was working, but now the joypad works. And then I decided at like 6 to solder on a speaker and an amplifier. So that might work, that might not work, but I'm hoping that I can demo it. I've got plans for this. I've not got plans there, but the next, this is not finished by any measure. I want to design the PCB so that I can actually put the CPU onto the PCB, because you get more Game Boys that are covered in corrosion, and like the traces are completely eaten, so you end up with a Game Boy that can't be recovered at all. But it's very likely the CPU and the RAM are fine, so you can lift those off, put them onto a new board, and make a consolizer out of it. So I think it makes sense to do that and then put the Pico on top. But yeah, so hoping I can show you a demo of a Game Boy loading, running all of its display through the DVI port into the HDMI display and reading the USB joystick. The only thing is, so when I disassembled everything to come here today, I decided I didn't need my debugging board. Completely forgot that was providing all the power. So now I'm going to run it where the power for the Pico is coming from the Game Boy, which, like I said, I don't really have a full understanding of hardware, so it might be okay, it might not be. If it doesn't work, you saw some slides. I can, yeah. Right, so I need to take out the HDMI. Yeah, that's it.
Cool.
Right, right, okay. Right, yeah, go around the table. Okay. Right, let's go through the hoop. There's still like resistors on here from when it needed a level shifter. I mean, that looks plugged in, right? Yeah, okay. I'm going to plug that into, I don't need that anymore. So hopefully the power's coming from my oh no, I've got to turn on Game Boy, there we go. I haven't even got a switch attached to it still. That's the speaker I attached. Do we have an HDMI image?
Go on. It
It should be putting a signal out.
May I?
You can.
Oh, I really, really, really want it to work.
I'm sure I've got videos. I don't actually, it's on the new machine. Oh, no one's got a small HDMI TV.
What kind?
Anything? On and off again. Oh, hang on.
Yeah, because the DVI it's technically not HDMI, but
Yeah.
it's usually compatible, so it could be that.
Isn't it?
Like this TV might not compatible.
Yeah, that's true.
Yeah,
But so
TV
let's.
was already a bit naughty.
Oh, really?
So then go back to HDMI 1.
Any chance as well? This is an HDMI capture, which might be able to go into your laptop.
Oh, what, the other way?
Yeah, so when you plug that there.
I can reset as well. They might. It's not. Okay. Okay. Well, hang on. Let's try another one then. So.
We've only got a few minutes, but we'll give it a go anyway.
Okay.
So you plug
That into
your
there.
laptop.
Okay. Hang on. I need.
We'll work this out.
Yep. It's in the laptop.
Okay. So if you open up QuickTime.
QuickTime. Set on that. I assume it's on.
No. Did it come up with?
Where's QuickTime?
And then you do File, New Movie Recording. And then you can change the camera to, it should be USB video. Yeah, that one. There we go.
Oh.
All right.
Okay.
Wait,
Yeah. Okay, we'll plug in another. Oh my. Well, this is. Isn't this hardware, right? It's just everything's plugged in multiple times. Okay. You did change it, didn't you?
Change it back. So change it. You can change it again. Think it'll make it. No. Oh, wait a second.
Hey. Do I have? There we are. Original. Oh yeah, there won't be any sound. These are all definitely games that I own, or I owned when I was a teenager. So I feel like, yeah. So this is all coming off the Game Boy. It's weirdly stretched. Oh, I thought that was the first Mario. I mean, I can hear it.
Is it from the speaker?
Yeah. Obviously, the amplifier is not. I think that the amount of power it's doing, but yeah. So USB, just like very much all randomly picked USB joystick. There you go. All right. So anyway, the point is, I wanted to make something that was cheap. They could run on very cheap tech, and I mean, the Pico. I think I picked those up a batch of 10 for like 10 or 11 pounds. So for £1 technology, I mean, the screen will probably cost way more. But yeah, anyway, it works. So there you go. You've got time for questions, or are you overrun? They literally ejecting you out.
Yeah, cool. Let's do some questions.
Anyone questions?
Are you the NodeMon guy?
I am the NodeMon guy.
Ah,
Yes.
excellent. Yeah, that's.
Anyone else?
Where do you go from here? What's
So
next?
I want to build the enclosure. So I need to sort out the audio. I'd like to make the audio stereo. It's currently mixing the audio into a single mono. Yeah. Actually, the other thing is I want to write software on the Pico because I've got the voltage signal from the game. It's the Game Boy itself. I can use that to say there's no Game Boy or game attached. And I've designed a screen that I also want to say when you plug in a new USB device, do the mapping. And I want to try and work out if I can take the event that says this is all the data of the USB command that you just sent, like up and right, and can I work that out from a diff of like what the up looks like? So I want to get a mapping for different USB ports. I want to do an enclosure, and the enclosure is going to have to start off as cardboard. And then I was like, can I 3D print it? And I was just like, it's a boatload of plastic. And it wants to be in wood, right? It needs to be in a wooden enclosure. So, yeah. Well, yeah, that's the thing. I was looking at Matt's project. I mean, but I wanted to be chunky wood as well. Like, I'm very jealous of the wood guy thing. But yeah, that's the next steps. And maybe don't burn myself as much. I literally had to change the Pico because the VSync line just wasn't coming up anymore, and the whole image was just rolling. And it turned. I'm pretty sure I hosed the Pico that I had it in. And it just eventually was just like, no, I can't see that signal anymore. Yeah.
Nice. Yeah. Thanks.
Cool. Okay. Well, cheers.
Anyway, well done. Just to let you know, we have got Street Fighter in an enclosure in the back there and downstairs.
Oh, so I could just take the enclosure and leave all the...
Yeah, exactly.
Okay.
Yeah.
Do you want me to get out of the way? I'll do...
Yeah, so Chetan, you're going to close us up, right?
Yeah.
All right.
Just going to kill that.
I'll be alright with this one. Yeah.
Cool.
Yeah. Thank you.
I'm lost as to what's plugging into where now. So that's in there. Okay, cool.
Hey, okay. Yeah, so I hope you enjoyed that. I'm going to do a quick, 2 minutes on this thing that I basically completely forgot I made until I was talking to someone earlier when I arrived here. Basically, I made a thing for my dad in lockdown. It was kind of a lockdown project. He was looking at wildlife cameras. So he's got a big garden and he gets a lot of birds and foxes and badgers and all sorts of stuff. And he's just like, I sort of see them at the corner of my eye, but then I don't get to really see them. And so he kept looking at all these different things, and there were so many to choose from, and all of them looked a bit janky, and you sort of had to, like, you shove an SD card in it, and then you go back through it, and then just, you know, when you remember, you'll kind of put the SD card in your computer, and you go through it and try and find all the videos, but most of them are boring and blank or whatever. So I was like, I can do better. So I made this little thing with a Raspberry Pi Pico. This is the Raspberry Pi camera. And these are actually like infrared lights, so it can see in the dark, which is quite cool. And that's basically the sum total of all the hardware. And most of the work was in software, to be honest. So I put it into this little project box, which you can see the corner of there, which had a sort of transparent top. So the whole thing was completely waterproof. I did try and run it off a battery, but actually I was using so much CPU that I could probably only run a battery for a couple of days, really. But anyway, it did work off a cable, so I just ran a 10-meter cable like into my dad's garden, and it was fine. But he lives in the Midlands. It was locked down. I couldn't really see him, so I actually had to send this to him in the post. So I had to put together a load of instructions. I also found out his Wi-Fi password, and I programmed that in here, so it could be online as soon as it got there. A thing called Motion Project, which is an open source thing which will look for videos, which will watch a video, and then when something changes on that video, it'll basically capture a chunk of video and then just store it as a file. And then I found someone who'd basically taken something that uses this sort of, Jimmy's the kind of like Google Photos API, so you can upload stuff to Google Photos. And I really wanted to use Google Photos because I know that my dad uses it, and I know it can do push notifications, and I didn't have to do any extra work. So basically, I made this thing just watch for videos whenever something moved. It would record a video, dump it into a folder, it would get uploaded to Google Photos, and then me and my dad were in a sort of shared photo album, and then we'd both just get a notification immediately being like, there was a bird or there was a fox, whatever. And so I'll see if I can show you. I mean, a lot of the time, to be honest, it just got trees swaying backwards and forwards, a lot of that. And a lot of work was just trying to get the Pi 0, which is very underpowered, to encode video efficiently, which I did manage to do, and took me months. It took me about a day to put the hardware together, about 2 months to do the software, so it gives you an idea of how it worked. It's all running on a thing called Balena Cloud. If you've never used that, it's really cool. Basically, you put together a Docker container, and it will just push the container out to your Raspberry Pi or whatever other thing you're using, and we'll just run it and keep it all up to date. So I had this one linked up to a GitHub repository, so I could just change the code, and it would automatically push it all up there. And it's all kind of managed remotely and all online, which is pretty cool. And here's some of the videos it took. There is a fox stealing a sock. What else have we got? There's a fox at night, which is quite cool. So you see, yeah, the resolution's not amazing, but I kind of turned it down just because I wanted to all run it off the Raspberry Pi 0, because I wanted the power consumption to be as low as possible, basically. Given it was on 24/7, I didn't want a sort of hot box just kind of melting itself in the garden, so it worked pretty well. Yeah, it was okay. In the end, my dad ended up just sort of leaving it at the front of the house and just using it to watch when the postman was coming. But, you know, it worked, so okay, cool. Yeah, so I just want to say thank you very much for coming. I thought that was really fun and definitely inspired me to kind of get the soldering iron and breadboards and stuff back out again. I hope you feel a little bit the same, and watch out for whenever we do the next event. Oh, yeah. In fact, we already have a date for the next event, which I think Charlie mentioned earlier, 31st of July. We have to get out of here as soon as we can, so if you could all kind of, yeah, what we're going to do is just head to the Joker for a pub, to the pub for a drink. So if you want to come and have a chat, come and say hi. Cool. Thanks very much for coming.